Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of sequence and series. This problem is very conceptual and was recently asked in JEE Advanced 2016. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, let us continue solving the problem. So we are given pi greater than 1 for I equal to 1 to 101. And suppose the natural log of b1, natural log of b2, natural log all the way to natural log of b101 are in AP with a common difference of natural log of 2. And suppose a1, a2 and all the way up to a101 are in AP such that a1 is equal to b1 and a51 is equal to b51. So in the second condition, we are not given the common difference for the series of a1 to a101. And there's a third variable also which is defined, which is bt is equal to b1 plus b2 all the way to b51, and s is equal to a1 plus a2 all the way to a51. Then we are given four sets of inequalities which we have to prove. Mind you, this is only one option correct type of a question. So let us begin. So natural log I'm going to write as ln. So ln of b1 and ln of b2 all the way to ln of b101 are in AP with common difference. Common difference I'm going to write with CD. Common difference of ln2, natural log of 2. Then this is by default. We know that you can refer to any textbook or any formula bank to find that b1, b2, b101 are in GP with common ratio 2. With common ratio, I'm writing as CR, common ratio 2. So when we have natural log of B1, B2 all the way to B101 and AP with common difference, then B1, B2, B101 are in GP with the common ratio 2. So we can write therefore B1 is equal to 2 power 0 B1, B2 is equal to 2 power 1 B1, B3 is equal to 2 power 2 B1 all the way to B101 is equal to 2 power 100 B1. Let us say this is equation 1. Now we are also given that A1, A2 all the way to A101 is in AP, and A1 is equal to B1 and A51 is equal to B51. Since a common difference for the series of A is not given to us, we will write A1 plus 50D is equal to A51. Now A51 is equal to B51, which eventually is equal to 2 power 50 B1. So what we have here now is A1 plus 50D is equal to 2 power 50 B1. This again I can rewrite as A1 plus 50, I missed the D here, 50D is equal to 2 power 50 A1. Now this I will define as equation 2. Equation 2. Now, the third variable which is given to us is t, which is equal to b1 plus b2 all the way to 51, b51. Now, since this is a GP series, the sum of the GP elements I can write as b1 2 power 51 minus 1 by 2 minus 1, which is nothing but 2 power 51 minus 1 in product with b1. So let me say this as equation 3. Finally, and S is equal to A1 plus A2 plus A51. Now this is an AP series, so the formula for the sum of the AP series element is S is equal to 51 by 2 minus 2A1 plus 50D. Now I'll say this as equation 4. Now the point of labeling these equations is that it becomes relatively easy to recall them later to address the problem. Therefore, I can say that t is equal to 2 power 51 minus 1 a1, because since a1 is equal to b1. So what I did, right, from equation 3 over here, what we have from equation 3, I just changed the term a1 to b1. Okay, so this gives me t is equal to 2 power 51 a1 minus a1. Now, this is naturally less than 2 power 51 a1. This is very intuitive because in this expression the term a1 is getting subtracted. So the term 2 power 51 has to be greater than this expression, complete expression over here. And s is equal to 51 by 2 a plus a1 plus a1 plus 50d. Now, if you recall equation 2, we already know that a1 plus 50d is equal to 2 power 50 a1. So I can very easily write s is equal to 51 by 2 a1 plus 2 power 50 a1. Okay, which means, now, okay, just to elaborate a little bit more, 51 plus 51 by 2, 2 power 50 a1. This term is definitely greater than 2 power 51 a1, and on that you are adding this. So I can very easily say that s is greater than 2 power 51 a1. Now, had this been equation 5 for me and this been equation 6 over here, using equation 5 and 6, using equation 5 and 6, I can very easily say that s is greater than t, because s is greater than 2 power 51 a1 and t is less than 2 power 51 a1. So I defined a common variable, which is common term, which is 2 power 51 a1, used that to find the inequality between s and t. Now going forward, I have A101 is equal to A1 plus 100 capital D. As I told you, the common difference for the series A was not given to me and I used the capital D for difference. And B101 is equal to 2 power 100 B1. Now from equation 2 actually, let me check equation 2, I can actually determine the value of capital D. Okay, so I'll just use that to my favor over here. I'll show you how. 101 is equal to A1 100 into 2 power 50 A1 minus A1 by 50. So from equation 2, I got the value of capital D, which I used applied over here. And B101 is equal to 2 power 100 B1, or maybe I can now write it as 2 power 100 A1, because since A1 is equal to B1, this is given to us. So finally what I have is A101 is equal to A1 plus 251 A1 minus 2A1, which is nothing but equal to, sorry, 251 A1 minus A1. So as you see that A101 is less than 2 power 51 A1 by the same logic. This term, I'm subtracting some value from it, so it has to be less than. And what I find that B101 is equal to 2 power 100 A1. So B101 is greater than 2 power 51 A1. Therefore, we have B101 greater than A101. So it is my second inequality. Now let's check our options. So S is greater than T and B101 is greater than A101, or A101 is less than B101. So if you do like the video, hit the like button, subscribe to our channel for more content like this. You can comment us the problems you want or the topics which you want more discussions on or more problem solving on. Thank you so much for watching.